Hello and welcome to example 10b. In this video, we find the volume of the solid revolution obtained by rotating about the x-axis through 4 right angles, the region in the first quadrant by the line y equals to x, which is this line. The lines x equals to 2, which is here. The curve 1 over x and y equals to 0. Now, because y equals to 0 is involved, we have to be understanding that the region has to have this blue line as part of its boundary. So the region involved will be this particular region. Many students will think that the area involved is the red region instead, and that will be a misconception. For this particular red region, it only involves y equals to x, the curve y equals to 1 over x, and the line x equals to 2. It will exclude y equals to 0. So because y equals to 0 is involved, we know that what we want is the region in blue. So let me re-sketch it out, and we have to be very clear about that. Now, because this region that we are revolving is bounded by different curves for different values of x, we need to split them into 2. What do I mean? If we find the point of intersection between y equals to 1 over x and y equals to x, we see that this point is 1, 1. So between x equals to 0 and x equals to 1, the region is bounded by y equals to x. But for the region between x equals to 1 and x equals to 2, the region is bounded by x-axis and y equals to 1 over x. Now, the blue and the red region are bounded by different upper curve respectively. So when we are trying to find the volume generated by the whole region, we will need to do an addition of 2 different volumes. I will proceed to explain why we need to add up these 2 volumes and why the volumes expressions are as such. In this diagram, the green portion is the region bounded by y equals to x. It is in the shape of a triangle, as I have illustrated earlier. This particular triangular region will generate a cone when we revolve about the x-axis. Because it generates a cone, we see that the volume of cone is 1/3 pi r square h. So we have this 1/3 pi r square h. The issue is, how do you see the r and the h in the cone? Now, if we get back to our volume of revolution here, if I see from the side, can you see that the base radius is actually 1, and the height of the cone is also 1? That you see this is the cone in our animation, and the height here is 1, and the radius here is also this radius here is 1. So height is 1, radius is 1. So volume of cone is 1/3 pi r square h. That gives us 1/3 pi 1 square times 1. Then we add on to the volume generated by the red shaded region. So we need to see and understand what that means. So okay, when we revolve the yellow region about the x-axis, we will end up with this red solid. So you can see that the whole volume of revolution involve two different solid, the blue and the red. So, and the red solid, the volume of the red solid can be approximated by the total volume of circular disc in this manner, similar to what we have seen previously. So circular discs are vertical. So over here, when we need to work out the volume generated by the red portion, which is over here, alright, so you can see that when we draw the circular disc this way, the circular disc is vertical in this manner, right? Similar to 10a, we know that the radius of the circular disc is given by y. So therefore, again, our volume of the solid of revolution here in red is given by the formula integration of pi r square, which is pi y square, dx, and the x values of x is starts from when x equals to 1 to x equals to 2. Now when we replace y by 1 over x, because this portion, the graph is y equals to 1 over x, so we replace y by 1 over x, we will have this integral that I have bubbled in red here. So upon simplification, we will find that we have the total volume to be 5 pi over 6 unit cubes.